Okay, so this is a video that is going to go over examples for basic math skills. And so far we've covered order of operations and solving linear equations. Okay, let's get. So I have a worksheet that I plan on just getting through all these examples. So fast forward if you see one that you would like me to work through, and you want me to skip over the other ones, you just got to kind of move the cursor on the YouTube video to the one you want. Okay, so I'm just going to start working through these. So order of operations, PEMDAS. So PEMDAS right here. The P is parentheses. Okay. The E is exponents. M is for multiplying. The D is for dividing. The A is for addition, and the S is for subtraction. Okay. So whenever we do examples like this, we want to keep that in mind as we're going through these so that we don't get mixed up. All right, first example. Change the width of my pen here. Okay, so move this up. We have 14 plus 3 plus 20 divided by 2 squared plus 5 squared. Okay, so the first thing that we want to focus on, and I'm going to use a red pen, would be the parentheses, because that's what PEMDAS requires, the P in PEMDAS. Okay, well, more specifically, within that, we have another set of parentheses right here, and also another one right here. Okay, so we're going to focus on this first set of parentheses first. Okay, so 14 plus 3 is 17. And anytime that I get rid of a parentheses, or anytime that I get a number out of it, the parentheses is going to disappear. So the 14 and 3 combine to get the 17, and that's going to make that parentheses disappear. I'm going to go over here and do this one next, 20 divided by 2, and that is going to give us 10. Okay, I'm going to bring down my plus sign. Now these parentheses are still here, and this squared is going to come down, so it's now 10 squared, and then the plus 5 squared is going to fall down as well. Draw that down. Okay, so now I'm on a different step, so I'm going to change colors. Okay, so now we still have a parentheses, so we need to focus inside this parentheses here still. But what we need to do next is look for any exponents, okay, because that's the E in PEMDAS. That's our second step, which we do. We have two exponents. We have one here, and we have one here. Okay, but since this one right here is in the parentheses, we need to do that one first. Okay, so I'm going to pull down my 17. And then I'm going to go ahead and do my 10 squared, which will be 100. Okay, still in parentheses. I'm going to bring my 5 squared down. And that will be the next term that we cannot work on this exponent here because we still have parentheses to deal with here. Okay, so let's continue on down. 17 plus 100 is 117. And now, since I have just a number, the parentheses are going to go away. I'm going to bring down my 5 squared. Now, I can work on this exponent here, because there are no longer any parentheses. So, 5 squared is 25. Bring down my 117. And my final answer is going to be 142. Okay, second example here. We're going to work through it. Okay, we have 12 divided by 3, all squared, plus, in parentheses, and in sub parentheses, 10 minus 4 times 6 squared. So, the parentheses, we're going to look at our first set, which is the 12 divided by 3. So that's what we're going to do first, right here. So, 12 divided by 3 is 4. And because I have just a number now, the parentheses go away. I'm going to bring the squared down. And I like to recopy everything over so that I know where I'm at. Okay, so we can't do this first part. We got to go on to the parentheses again because in PEMDAS that is our order. So within this parentheses, I see another sub parentheses with 10 minus 4, so I'm going to go ahead and do that, which is 6. I'm going to bring this 4 squared down. Okay, this big parentheses is still here, but the smaller one has gone away. Times 6 squared. Okay, so we still have parentheses. Within the parentheses, I see an exponent, so I need to do that first. Okay, 6 squared is 36. Go ahead and bring everything down. So we still have parentheses, so 6 times 36 is 216. Now we have a number, so our parentheses go away. 4 squared. Now we can do that, which is 16 plus 216. And so our final answer is 232. Okay, example number 3. We have 6 squared plus 18 divided by 9 plus 5 squared, all minus 3 squared. So I see 2 sets of parentheses, and so I'm going to focus on the inside ones first, right here. And within that, I have an exponent, so I need to focus on that first. So let's do that. That is 25. I'm going to recopy everything down so that I'm consistent. I still have my parentheses here and here. The 6 squared gets copied down. Those are in parentheses, minus 3 squared. Okay, next section would be to continue with the inside parentheses. And I have division and addition. So I'm going to do division first because in PEMDAS the M and the D are multiplying and dividing, so I need to do those first. So 18 divided by 9 is 2. Copy this down. Oh, excuse me, made a mistake. Okay, 6 squared plus, going to bring that down, parentheses, minus 3 squared. Okay, inside the parentheses still, I'm going to get 27. Parentheses go away because I have a number. And 3 squared. Okay. So I have parentheses still, and I'm going to focus on the exponent. That's what I would do first. I get 36 plus 27. That is in parentheses, minus 3 squared. 36 plus 27 is 63. Parentheses are gone. Minus 3 squared. I focus on the exponent because I don't want to subtract before I do an exponent. So 3 squared is 9. So 63 minus 9. And I get my final answer of 54. Okay, next problem, number 4. 6 squared plus 8 divided by 4 plus 3 squared minus 4 squared. Okay, so focus on the parentheses inside the parentheses, more specifically the exponent here. So I'm going to get 3 squared, which is 9. I'm going to copy everything down. And then 6 squared plus, that is all in parentheses, minus 4 squared. This one's a little similar to the last one we did. So focus on the parentheses. 8 divided by 4 is 2. Bring down everything else. Still on the parentheses, 2 plus 9 is 7. 6 squared plus minus 4 squared. Still in the parentheses, 6 squared is 36 plus 7. minus 4 squared. 36 plus 7 is 42. Excuse me, that is 43 minus 4 squared. 4 squared is 16. 43 minus 16 is 27. Final answer. 18 minus 3 minus 20 divided by 2 all squared times 7 squared. Okay, I'm going to focus on the parentheses inside the parentheses, more specifically the one on the left. So 18 minus 3 is 15. Copy everything down. Okay. I'm going to focus on the other parentheses inside the parentheses. So 20 divided by 2 is 10. And that squared is going to come down. Times 7 squared. 10 squared is 100. 15 minus 100 times 7 squared. 15 minus 100 is going to be negative 85 times 7 squared. Well, 7 squared is 49. So we have negative 85 times 45, times 49, and that's going to give us a final answer of 4,165. Okay, I'm going to stop there because all these examples are basically the same in the next set of 6 through 10. So I'm going to move on to order or solving linear equations, the algebra behind it, on the next slide. Okay, continuing on with solving for a variable in linear equations. We're going to move on up to this example here. And again, if you saw one at the beginning that you really want me to work through, then just let me know. Two t minus 3 equals 9 minus 4t. Well, first step is to combine like terms. So I am going to add 4 to this side. I'm going to add 4t to both sides. And when I do that, this is going to cancel out the negative 4t and the positive 4t. So I'm left with 6t minus 3 equals 9. Well, now it's my job to get the numbers on the same side. So I'm going to add 3 here, add 3 here, and what that does will cancel these 3's out. So I'm left with 6t equals 12. To get rid of the 6 and to have the t by itself, I need to divide by 6 on both sides, which cancels that. So now I have t equals 12 over 6, or t equals 2. Okay. Moving down. 2 times y minus 3 plus 6 equals 70. So, first step would be to distribute this 2 across to the y and across to the 3. So, we have 2y minus 6, which is 2 times 3, plus 6 equals 70. Well, the negative 6 and the positive 6, they're going to cancel. So I'm left with 2y equals 70. To get rid of the 2, I divide both sides by 2. That cancels. Y equals 70 over 2, which equals 35. Okay. 2x minus 5 equals 17. So the first step would be to add 5 here, add 5 on the other side. It's going to cancel the 5's. 2x equals, and then 17 plus 5 is 22. We're going to divide by 2 on both sides, which cancels this. X equals 22 over 2. X equals 11. Next example, t minus 2 times 3 minus 2t equals 2t plus 9. So first step is to distribute this 2 to the 3 and to the negative 2t. So we're going to have t minus 6, and again, this negative sign will transfer with it, with the 2, as we distribute. So negative 6, and then negative 2 times negative 2t would be plus 4t equals 2t plus 9. Okay. So we need to combine terms, so we can go ahead and combine these t's on one side first, which would be 5t minus 6 equals 2t plus 9. Well, now we need to get the t's on the same side, so I'm going to subtract 2t from both sides, which will cancel those, and I'm left with 3t minus 6 equals 9. To get rid of the 6, I'm going to add 6 on both sides. Cancels that. Left with 3t equals 15. Okay, need to divide by 3 on both sides. That cancels. So I'm left with t equals 15 over 3. So t equals 5. Okay, moving on. 7 times 3 minus 0.5k equals 3k minus 5. This is first step. Distribute the 7. 7 times 3 is 21. Minus, and then that's going to be 7 times 0.5, which will be 3.5k equals 3k minus 5. Okay, so we need to get the terms together by combining the like terms. So I'm going to add 3.5k to both sides. That's going to cancel there. 21 equals 6.5k minus 5. To get rid of the 5, I will add on both sides. This cancels. So I'm left with 26 equals 6.5k. And when we divide by 6.5 on each side, k equals 26 over 6.5. And when you do that, k equals 4. Comes out nice and neat. So there's one more example that I'd like to work out. And I'm going to zoom out here. And we're going to work on this one, because I think looking at it may be a little daunting. So we're going to go through it. Okay. So the first step here, I want to get rid of this 3. And to do that, I'm going to multiply both sides by 3. And when I do that, that's kind of like saying 3 over 1. It's just a whole number. It's 3. But what happens is, because the 3 here is on the top, the numerator, and this 3 is on the bottom, they're going to cancel each other. Okay. Okay, and from there, we're going to have x plus 5 equals 12. 4 times 3 is 12. To get x by itself, we're going to subtract 5 from both sides. So, x is going to equal 7. Okay.